added a few things here, uh, very minimal on our yesterday lecture notes. I have added this rotation about which axis? So it is a rotation about the z axis by an angle of theta. You could see this angle was theta. So this angle is theta. And I have also added this sentence here that says orientation of frame 1 with respect to frame 0 when frame 1 is rotated with respect to 0 by angle theta about the z axis. So this indicates it's the orientation matrix of the frame 1 with respect to frame 0, and the rotation is pure rotation about z axis by an angle of theta. And yesterday we saw how we obtained these elements. So let's proceed now. Let us take uh, if the frame 1 is rotated with respect to frame 0 about the y axis. So I've already prepared something before so that we save some time. Yeah. So here you can see that we have got y0 and y1 as if they are coming out of the board. And the rotation, we are interested now in having the orientation matrix, orientation of the frame 1 with respect to 0. And this indicates that it is orientation of frame 1 with respect to 0 about the y-axis by an angle of beta. Okay. And we have the R matrix, the structure of the R matrix here, and yesterday's empty box. We have to fill up the elements. So now we have orientation of the frame 1 with respect to frame 0. When frame 1 is rotated with respect to frame 0 by angle beta about the y-axis. So if we proceed with this, let us start determining. So first of all, we will identify the unit vectors. You can see I have deliberately taken, since the rotation is about the y-axis, I have deliberately taken y0 and y1 as if they are coming out of the board. So if we use our right hand and if our thumb points towards the y-axis, then turning from z-axis towards x-axis will give us the positive direction of the y-axis. The thumb will give us the positive direction of the y-axis using the right hand rule. Okay, so this is what we have made use of over here, and so we are turning from the z-axis towards the x-axis. So we have placed z0 here and x0 here. And as we had done yesterday, we have taken the frame 1, rotated with respect to the frame 0 by an angle of beta about the y-axis. And then let us identify the unit vectors. This is going to be the unit vector k0 because it's the z-axis. So the unit vector k0. This is going to be the unit vector I0 because it's along the x-axis. In the same way, we will also have the unit vectors. Here we will have j. So here we'll have k1. This unit K1, and here we will have this unit vector as I1. So we have got all the unit vectors, and so we are set now. The two unit vectors J0 and J1, they are coming out of this plane towards the observer. So let's start. I1 dot I0. So when you resolve I1, the vector I1 in the frame 0, you can take the components of this I1 resolved along I0. So this is I0, this is I1. So this component is over here. This component is I1 dot I0. I1 dot I0. And that is equal to, you can see it is cos of beta. So I will write it in abbreviation. I'll write it as CB, indicating cos of beta. Okay, so this is in the same way. So we'll fill it up here. This element is cos of beta. Then I1 dot J0. We have I1 here, and we have J0 coming out of the board. So naturally, this is going to be 0 because they are mutually perpendicular. Then I1 dot K0. I1 is here and K0 is here. So the projection of I1 on K0 will correspond to this vector here. Okay, so this, now you can see it is pointing in the negative direction of K0. So we will have to take this as I1 dot K0, and this is equal to minus, what is the magnitude? The opposite sign of this towards this angle, so it is equal to minus sine of beta. All this we are doing because we are dealing with a, and so this radius is 1. Okay. So here we are going to write this as minus sine beta. Here we have J1 dot I0. J1 is coming out of the board, I0 is here, they are mutually perpendicular, so this element will be 0. Then you have J1 dot J0. Again, J1 and J0 both are in the same direction, their magnitudes are 1, so the dot is going to be J1 dot K0. So again, this will be 0 because they are mutually perpendicular. Then K1 dot I0. K1 is here and I0 is here. So it is a projection over here. This is the projection. This projection we identified like this. This is K1 dot I0. And this is corresponding to, write it here. This is going to be sine of beta because it's corresponding to the opposite side. So this is sine of, and direction is positive. So this will be sine of beta. K1 dot J0. K1 is here and J0 is coming out. So this is going to be 0. And K1 dot K0. K1 is here, K0 is here. Projection of K1 on K0. This is going to be K1 this is K1 and that is corresponding to the adjacent side of this angle. So this is cos of theta and it's in the positive direction. This is cos of. Now let us look at this structure. You find that because the unit vectors J0 and J1 they are coinciding, there is no rotation about these vectors, and so this unit vector remains unchanged. You see 0, 1, 0. This is the representation of the unit vector J1 in the frame 0. It remains unchanged 0, 1, 0. And here the components certainly change. But you can see that the magnitude of each of these columns is just equal to 1. The same thing applies for the previous case also, where we had taken, you look at it carefully here, the rotation was about the z-axis. So the z-axis, that is the third column, remains unchanged. Third column indicates the unit vector K1 as expressed in the frame 0. It is 0, 0, 1. Okay? And the other columns, all these columns have the same magnitude. You can see, you square up these elements and add them up, take the square root, you will get it as equal to 1. This, and this. So the structure looks like this. The diagonal elements are cos thetas and the off diagonal elements are sin thetas, and you know the sign changes, but here you have cos theta sin theta minus sin theta cos theta. A slight change over here. It's a bit tricky for the y-axis. So here you have this unchanged, of course, cos beta here. But here you have minus sin beta and not sin beta. You have minus sin beta and here you have sin beta. So this is the orientation matrix for representing the orientation of frame 1 with respect to frame 0 when frame 1 is rotated with respect to frame 0 by angle beta about the y-axis. In the same way, I think you can also do the orientation about the x-axis. This is relatively easier because here you will have to take the axis y0 here and z0 here, and y1 and z1 they are rotated, and we are considering a rotation by an angle of gamma. Naturally, because we are considering the rotation about the x-axis, x0 and x1 they're coming out of this plane. This is the origin. Let's indicate the unit vectors. They are already indicated here. So we have J0, we have J1, we have K0 and K1. The unit vectors are also shown. Now let us write down the components. So for the components, I1 dot I0. You can see that both I0 and I1 are coming out of the board. Both are in the same direction. So this will be 1. I1 dot J0. They are mutually perpendicular. So this will be 0. I1 dot K0. They are mutually perpendicular. This will also be 0. So you can see the first column is remaining unchanged. Okay. So first column is remaining unchanged. Coming to the second one, you have J1 dot I0. They are mutually perpendicular, so this will be 0. Then J1 dot J0. You have J1 here, you have J0 here. So this component here is J1 dot J naught. J1 dot J naught. That is equal to cos of gamma. So we can write this as cos of. This is J1 dot K naught. J1 is here and K naught. K naught is here. Projection of this over here is here, this one. This is J1 dot K naught. And this corresponds to its opposite side of gamma. So this is sine of gamma. So here we will have the sine of here K naught, K1 dot I naught. I naught is coming out of the board. K1 is in the plane. So here this will be C. K1 dot J naught. K1 is here dot J naught. J naught is along this horizontal. So naturally this is the component pointing in the reverse direction. So naturally this is going to be negative. You have K1 dot K1 dot J naught. And this is going to be equal to sine of minus sine of gamma. So this is minus sine. And finally here we have K1 dot K naught. K1 is here, K naught is here. So this is the component. This is K1 dot K naught. And this component is equal to, it's the adjacent side, it is cos of, yeah. So we have worked out the standard orientation matrices for when the frames are oriented or rotated with respect to the frame 0 about the z axis, about the y axis, and about the x axis. We have done this one by one. Of course, these were pure rotations. The point to be noted here is that in all these rotations we had considered the origin for both the frames as coinciding with each other. Okay. Now let us take, just to reinforce our concepts, let us take so we have this parallelepiped here. We can see that one side is units, the other is 3 units, and this is 4 units. We can also number these, let's say, use numbering. Let's give them, say this is A, we label this A, B, C, D. E, F, G, H. So we have these. This. Let's fix up a frame of a different color. Let's say. So we have two frames. Let us say the frame in black is frame 0, We'll indicate it using the notation for frame 0, and frame in red here is the frame 1. Frame 1 is represented like this. So we have the origin of 1, it's coinciding with the point G. We have not decided what should be the directions, and deliberately I'm taking this as if we take this as x, x1, this one will be, if we take this as y1, then using our right hand rule, we'll have z1 pointing downwards. This will become z. Okay. Now you have to figure out what is r1 with respect to 0. What is this orientation matrix? Again, we are going to use the same concept that we had earlier. Save our work, whatever we had done. Now, how are you going to determine what is going to be the orientation of frame 1 with respect to frame 0? So again, it's exactly the same way. So let us take for a change. Okay, let's take it as red only. So the first element here, I1 dot I naught. So let's identify I1, I naught, etc. So this is going to be the unit vector I1, I1. This is K1. And naturally, this is going to be J1. And here we have unit vectors I naught, then we have J naught, and K naught. So let's work out the first element, I1 dot I naught. You can see I1 is this vector and I naught is this. You can see that they are mutually perpendicular to each other. So this element will be 0. Then I1 dot J naught. I1 dot J naught. You can see both of them are opposite in direction, although they are parallel, but they are in the opposite direction. So it is, if you view from the frame 0, if you look at I1, it's pointing in the negative direction, but it's parallel. So you will put here -1. And then I1 dot K naught. I1 here and K naught mutually perpendicular. So this will be 0. And you can see, you should verify for yourself that the magnitude of this column should be 1. So this is our first column. And coming to the second one, J1 dot I naught. Our J1 vector is here, dot I naught. You can see that both are again in the opposite directions. So this will be -1. Okay. Then J1 dot J naught. J1 is like this and J naught is like this, so they are mutually perpendicular. This is going to be 0. J1 dot K naught, J1 is like this, K naught is mutually perpendicular. थोड़ा बाद में, this will be 0. This is K1 dot I naught. So K1 dot I naught, we have K1 here and I naught. I naught is perpendicular. If you draw this parallel to this, you will get K naught, K1 and I naught. So this is going to be 0. K1 dot J naught. K1 is here and J naught is here. Again, mutually perpendicular. K1 dot K naught. K1 going downwards, K naught going upwards, although they are parallel. So this is minus 1. Again, you can check for yourself all the magnitudes. Magnitude of each of these columns is 1. This is our R matrix, specifying the orientation of frame 1 with respect to frame 0. I hope this example is clear to you. In the same manner, you can take, let's take another color. You may take some other direction. You may consider say one axis here. So here we will have, let's designate the axis. Let us take this as X, this is Y, and then naturally Z will be upwards. So let's take this as X2, Y2, and naturally Z will be perpendicular. So I'm not showing that. Okay. So the assignment for you is that you have to find out R1 to 0 for R2 to 0. Sorry. R2 to 0, where 2 is this frame which has been indicated. This is frame 2. The z-axis has not been shown, so you have to find out using the right-hand rule, and you have to work out the components of this. So this is a small assignment for you. Okay. Let us also take another homework. Let us rotate. Let's have another axis. Let's take it in blue color. Take this axis. So this let us take as one of the axis, and we take the other axis as if it is passing through this vertex. We are indicating only two axes. The third one is going to be mutually perpendicular to it, to these two axes. So let us take this as x3, x3, and this as y3. Okay, and let us take this as the frame 3. The frame 3 is in blue, and you are also asked to determine the orientation of frame 3 with respect to C. So this is another assignment problem for you. This is some homework problem, homework 2, and this is homework 1. Is anyone having any query in what we have done so far?